Hi again. So last video was way too long, so I hope to keep this one as short as possible. So today we're going to be going through Pascal's expansion, so how we can use Pascal's triangle to expand out brackets and briefly touch on combinations. So again, I just want to go through the basics. So combinations refers to the number of ways that you can select R items from n distinct items. So let's say I had like 5 pens, and I wanted to find out how many ways I could select 2 pens from these 5 pens. So we're just going to use this formula which tells us the number of combinations. So you take the top number, factorial, then bottom number multiplied by their difference, factorial. And in this case this happens to be 10. Another way that you can write this is in brackets 5, 2, like that. That's a notation that I often use, so just keep that in mind, but they're the exact same thing. Also notice that if I was to choose 2 pens from 5 pens, that is going to be the same as choosing 3 pens from 5 pens, right? Because by selecting 3, I'm also not selecting 2. So that's where we get this new formula, which is for any n choose r, it's going to be equal to n and then n minus r. By selecting r objects from n objects, I'm also not selecting n minus r objects. So that's just how it works. Now let's revise Pascal's triangle. So it's basically a special triangle with one at the top and then 2 ones at the next row. And then below that, every number is the sum of the 2 terms above it. So let's take 6. That's equal to 6 because 3 plus 3 is 6. So to get the next row, we would have to add, so it starts with 1. Then we go 6 plus 1 is 7. 15 plus 6 is 21, etc. So that's just how it works. Also notice that we number each of the rows starting from row 0. So the top row is row 0, then row 1, 2, 3, etc. Now every sum of terms in each row of Pascal's triangle is 2 to the power of n, so 2 to the power of the row that they are in. And also you can rewrite Pascal's in this sort of form, because notice that each row in Pascal's corresponds to a row in the other sort of triangle. So they're actually the same thing. This is just how Pascal is like derived, I guess, because it's like each combination of things, right? Like 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And if you order them like that, that's how you get Pascal's. Pascal's triangle is really important for when we want to expand things out. So I'm going to start with a simple example of how it works, and then I'll have some sample questions at the end. Let's start with an easy example, x plus y in brackets squared. So ordinarily, if we wanted to expand this, we would write it out like this. And then we would do the thing where it's like x times x plus xy plus another xy plus y squared. So that gives us x squared plus 2xy plus y squared. So this approach is fine, but when the numbers get bigger, like x plus y to the 5, then we don't want to have to use that manual method because it's like way too long. It's going to be like way too annoying. So this is where Pascal's triangle comes into play. So this is just an easier method to expand out larger things. So first what we're going to do, we're going to like list out all the possible combinations of the 2 terms, in this case x and y, so that the powers add up to 5. So for example, start with x to the 5 and then y to the 0 plus x to the 4, y to the 1 plus x to the 3, y to the 2. So notice how like the 2 terms always add up to 5. X to the 2, y to the 3, x, y to the 4, and then y to the 5, and then x to the 0. but anything to the power of 0 is 1, so we can technically get rid of this. Now all that's left are the coefficients. So for this one, we're going to look at the power, which is 5, and we're going to look at the fifth row of Pascal's triangle, which is this one, row 5. And all we're going to do, we're just going to insert those coefficients. So 1, 5, 10, 10, 5, 1. And then we're done. This is the correct answer. However, in a test situation, especially if they say like show use of Pascal's triangle, that sort of thing, you should probably refer back to this triangle. When you're showing out your working, probably in the line before, instead of writing like 1, because you're in the fifth row, which is this row, instead of 1, you would write like 5, choose 0, x5, and then 5, choose 1, x4, y. You should probably write it full like this, especially if you have time, because I've just noticed in a lot of answer sheets they want you to write it like that. But just remember that it's the same approach, it's just written in combinations basically. So on your test, your first line of working would be this, and then you would do this. And then if you have to expand out anything, then you have to do that as your final answer. So I think it's a pretty simple process, you just need practice. So let's do some questions.